All right, good morning, everyone. I think we're ready to get started. Welcome back to day 2 of our technical workshop. You can maybe grab that last cup of coffee, glass of water. I think we're ready to get started. So good morning and welcome. Hope everyone had a nice evening. It's a good thing we start at 9 o'clock and we learned from before not to start at 8. So hopefully everyone got a little bit of extra rest. All right, so for today, I'm going to first start off by handing it over to Brenda. She's going to do a little bit of reminders for those of you who are virtual. I think those of you in the room sort of have it down, but wanted to just welcome everybody who's joined us virtually. And Brenda, if you want to do the reminders for how we're going to facilitate today's meeting.
Of course, thank you. So for today's reminders, on the next slide, we will have this meeting recorded for information convenience purpose only.
There you go. Whoops.
Any related transcription should not be reprinted without the ISO's permission. These calls are structured to stimulate open dialogue and engage different perspectives in understanding the material to designing solutions for EDAM. In interest of time, please refrain from repeating or reiterating anything that was already said. And if you do need any technical assistance during the meeting, please send a chat to my event producer, Roy. For any questions for those in person, please raise your actual hand so we can get you a mic over to you. Make sure you state your name and organization when asking your question to ensure our virtual participants can hear your question and who is speaking. And for our virtual attendees, please use the raise hand icon located in the Zoom feature or submit a question through chat. Also, please state your name and organization when submitting or asking your question.
All right, thanks, Brenda. So in terms of today's agenda, we've got 2 main conversations or discussions that we're going to be hosting. So the first one is modeling of GHG accounting approaches by George Angelides. I think everybody's familiar with George. He's our executive principal of Power Systems and Market. And so we look forward to hearing from George, and I'm sure we're going to have some great mathematical equations to review. And then after the break, we will cover settlement of GHG awards under different approaches, and that's going to be presented by James Lynn. He's our senior advisor of market settlement design, and I think he was up late last night working on some spreadsheets, so I'm sure we're going to be looking forward to seeing some of his spreadsheets. So on the panel this morning as well, we have Anya Gilbert joining us, Mark Rothleader, and Milos Bosanek for Q&A sessions. So with that, I'm going to turn it over to Anya, who's going to tee things up.
Sure. So we got a lot of feedback that examples and a modeling approach for both the resource-specific and zonal would be helpful. Since then, we also received some updates on LEDWP's proposal. And in response, this morning, we're planning on going through some examples that review all 3 approaches using a basic model that George has developed. We're going to start out this morning by going through the example setup through PowerPoint. That is available online. I do recommend using Edge to open that up. And then we'll go through the model itself. And so with that, I'll turn things over to George.
Thank you, Anya. This is George Angelides with the ESO. So we're going to be working some examples of the various greenhouse gas models. And we have developed these examples with Solver, the model that was developed in Excel. We have released that for your information. It has even more complicated examples than the ones that we're going to walk through today, which are more simple. And we have released this tool for your use if you want to make your own examples and understand how these models work. As usual, we don't provide support for these tools, so made available as is. Anya will be helping me going through the slides, and she will be advancing the slides. And later on, after we go through the simple examples, we may have some time to have a look at the model and explain how it works. Thank you.
Maybe just
Anya, you may advance. Yeah.
Sure. I think we're going through a process to switch the slides on our end to a different deck.
Okay.
All right, here we go.
All right. Thank you, Anya. So we wanted to have a complex enough example to show the features, the salient features, and how they work for these different models. So we start here by having three balancing authority areas, A, B, and C. And we wanted to have more than one greenhouse regulation area. So we have two greenhouse gas regulation areas, 1 and 2. And we also wanted to have these greenhouse gas regulation areas not aligning perfectly with balancing authority areas, so that we bring out all the salient features and illustrate how this would work in general. So greenhouse gas regulation area 1 is a portion of BAA. So there are resources in BAA that are not subject to the greenhouse gas regulation of area 1. And similarly, greenhouse gas area 2 is also a portion of BAA-B. So again, there are resources in BAA-B that are not subject to the greenhouse gas regulation of area 2. And the portions of BAA-A and B that are not subject to greenhouse gas regulation, along with BAA-C, form what I refer to as greenhouse gas area 0, which is the area that does not have greenhouse gas regulation. We show here the BAA to BAA transfers. These are the blue arrows. We are already familiar with these transfers. We have talked about this in EDAM in many occasions. We have these transfers in the form of energy transfers today in EIM, and we expanded the concept in EDAM. We have different buckets for these transfers, and we have even different commodities for these transfers. With the greenhouse gas regulation model, we're introducing another set of transfers. We call them greenhouse gas transfers, and this is a transfer from area 0 to each of the greenhouse gas regulation areas. So these are shown here as red, that's TN1. It's the transfer from area 0 to area 1. And with green, we show the transfer from area 0 to area 2. And the same way that we calculate the BAA to BAA transfers, being the mismatch of the power balance constraint for each BAA, like generation minus load, is the net transfer into a BAA, which is an algebraic quantity. If it is positive, it's an export. If it's negative, it's an import. The same concept applies with the greenhouse gas transfers. So that transfer T1 for area 1, it's really the difference between generator G1 and the load L1. This is the transfer. If it's negative, it's an import. As you see, we have to separate the load that is traditionally represented as one aggregate load resource for each BAA in EIM. Here in EDAM, now we have to take the next step to accommodate the fact that the greenhouse gas regulation area does not align perfectly with the BAA boundary. We have to separate the load into the load that is subject to greenhouse gas regulation, which is here L1 and 2 for areas 1 and 2, And L3 and L4, which is the load outside the greenhouse gas regulation area, that is not subject to the greenhouse gas regulation. This is important because there are different LMPs that apply to these loads, as we're going to show in the context of these examples. Let me take a pause here and see if there are any questions on the setup that we're going to use for all the examples that we're going to walk through today. Make sure that all these elements are understood.
I'm not seeing any questions in the room. Brenda, do we have any questions online? No. George, you can keep going.
I do. George, sorry.
Thank you.
Mark, I just have a clarification. So you represent the transfer from area A to area B, and so that transfer is inside the non-GHG zone, not a transfer from the GHG area 1 to area 2. So is that a GHG transfer, or is that just a transfer from non-GHG to non-GHG area?
Mark, are you referring to TAB, that blue arrow, the vertical one? As
Yes.
a transfer between BAA and BAAB? Okay, so that's a BAA to BAA transfer. It's not a greenhouse gas transfer. Okay. Essentially, if you write the power balance equation for BAA, which is G1 plus G3 minus L1 minus L3 equals T, that T is the net transfer for BAA, and the model divides this across the various individual transfers. Here is TAC and TAB. This has nothing to do with the greenhouse gas transfer, which is the red and green. These are transfers into each of the greenhouse gas areas. So the quantities are not related directly. However, they are co-optimized by the model. Are there any further questions? Okay. All right, so we added some bids here, okay? Just give me a second, Anya, don't advance yet, stay where you are. So intentionally, we made the generators in the greenhouse gas regulation areas 1 and 2 expensive, because we want to have a solution that shows a greenhouse gas transfer into these areas, right? Because that's the objective of these exercises, to see how the greenhouse gas transfers are calculated and then what kind of revenue we collect for them. The rest of the resources in BAA and BAAB is a little bit less expensive, and the resources in BAAC are the cheapest resources, G5 through G8. So the first example that we're going to walk through here is the resource-specific or dimming approach that we have essentially applied for years in EIM, and we are considering it as a way to one possible way to solve the greenhouse gas regulation problem in ADAM. All right, let's see some more numbers, Sonia. Okay. So again, if we have time, we're going to walk through the Excel model and illustrate how this solution is obtained, although the prices are selected in such a way so that it's actually easy to derive the optimal solution by visual inspection. So let's talk about the bids. So we show in black is the energy bid. Every resource has an energy bid. We assume that they bid for the entire capacity, its generator. And then we have the greenhouse gas bids. Greenhouse gas bids, only resources in area 0 have greenhouse gas bids for each of the greenhouse gas areas. So for area 1, the red bid is the greenhouse gas bid other. And for area 2, the green bid is the greenhouse gas bid other. You can see that G3 bids for both areas, $5. It could be different bids for different areas, but for simplicity in this example, I consider the same bid at $5, $4 for G4. And then if we look at BAAC, G5 elects not to bid greenhouse gas bid other. This is in the resource-specific approach. Submitting bids for greenhouse gas others is optional. Generator 6 elects to bid only for greenhouse gas area 1, so you see a red bid at $1. Similar with generator 7, a red bid for $2. And generator 8 submits a bid for each greenhouse gas regulation areas at $3. So that's our input in terms of bids. Okay. And if we look now at the optimal solution, the purple values are the optimal schedules. Obviously, because the generators in area C are the most economic, you will see them being scheduled at a full capacity of 200 megawatts. And since you have a 400 megawatt load in area C, there is a 400 megawatt surplus generation in area C. So that will result in a 400 megawatt net export transfer. That's the BAA transfer, the blue arrows. 300 flows from C to A and 100 from C to B. And the balance of the power for serving the load in areas A and B will come from the next generator that is cheap. That's generator G4. Will also be scheduled at 300 megawatts, its total capacity. And then we're still needing 100 megawatts, which will come from generator G3, which is marginal and sets the price at $70 with its bid. Since we don't observe in this simple example any scheduling limits on the BAA transfers, and none of them is hit, basically you see the $70 marginal energy price throughout the grid. So also in BAAC and BAB, $70. Now, there is an additional cost, an additional LMP component in greenhouse gas area 1 and area 2. And let's see how this is coming about. You want to have the load in area 1 and the load in area 2, a total of 400 megawatts, being served by outside of the greenhouse gas regulation areas because the generation inside these areas is very expensive. And it's more expensive than what will take for outside energy plus whatever the relevant greenhouse gas bid other is. So the optimization model will end up having a you see that red transfer here.
George, you cut out for just a moment, but this might be a good time to pause and see if folks have any questions. I know that there's still some setup that needs to be done, but it looks like there's some questions that have come in on the remotely. Go ahead, Brenda.
We do have a question from Callie Wells. Operator, please unmute.
Hi, this is Callie Wells with WPTF. Can you hear me okay?
Yes, we can.
Okay, I don't know. Did we just lose George? Because on my end, it looks like his video just froze.
Yes, it looks like George dropped off, so we'll give it a moment just for him to reconnect.
Okay, and if you want me to defer, I can wait till he's done walking through this example. I have some questions on the pricing and the dispatch. So if you'd rather me hold off until he's done with the slide, I can do that as well.
Looks like we have George back, if you want to go ahead.
Okay, you want me to go ahead?
George, do you have your audio?
Okay. Yes, I'm back.
Go ahead, Callie.
All right. Good morning, George. First of all, thank you for putting together all these examples. It's really helpful to have us walk through with some actual numbers and so we can see the differences between all the approaches. I have a couple questions on this resource-specific approach. So my first question is, I noticed in this example, that there aren't any baseline or counterfactual schedules? Are you assuming those are all zero for simplicity purposes?
Yes, very good question, and I forgot to mention that. So for simplicity, I considered a zero reference for this example. So essentially, you could potentially have a full greenhouse gas attribution to the resources that submit bids, greenhouse gas bid address. We normally have as part of the resource-specific approach, we're using a reference that is, and then we limit the attribution to the difference between your upper economic limit of the bid and that reference. So I'm using a zero reference for this example. In the Excel model, there are also examples that I'm using a non-zero reference there. It introduces a certain complexity. So for the purpose of these simple examples, I did choose a zero reference so that we can focus on the mechanics. And then if we have time, we can see the effect of the non-zero greenhouse gas reference. Thank you, Kelly.
Okay, great. Yeah, because I think just based on the conversations yesterday, one of the biggest, I think, differences or concerns among the various approaches that they're all trying to address is that secondary dispatch issue, which obviously comes when you have the baselines with the resource-specific approach. So I think it'd be useful whether or not we have time today or maybe in the next iteration of the proposal, you can walk through some examples of all three approaches that have to show kind of how they all differ in terms of addressing that concern. My second question is on the pricing. So I know today in the EIM, when you have the GHG component, it is a negative LMP component, the non-GHG area. So I see here you're proposing now to kind of flip that to where the LMP component is positive in the GHG areas and zero in the non-GHG area, which I think makes intuitive sense. My concern or question is, in this example, you have the SMEC at $70, which is based on a resource in the non-GHG area. In the event you have the SMEC actually being set by a resource in the GHG area, that its energy bid includes the cost of GHG embedded in there, and then on top of that, you're going to add a positive GHG component. Is that double counting of GHG costs because you have the positive GHG component separate, and then within the SMEC is also the reflection of that resource's GHG cost, because the current proposal is still to have all resources in a GHG area embed their cost in their energy bid.
Yeah, these are all good questions, Kelly. Let's break them down and take them one by one. So indeed, in EIM today, we formulate the greenhouse gas constraint, and I need to explain what that is here. This constraint essentially distributes or allocates, if you will, the greenhouse gas transfer to the selected bids. So I didn't have the chance to finish this example. I think I will go ahead and finish while answering your question because it's relevant. So what I was saying before we broke for questions is that what you're going to see from the model, the optimization will maximize the greenhouse gas transfers to areas 1 and 2 because the generation in areas 1 and 2 in this example is selected to be expensive, right? So you're going to have a 110 greenhouse gas transfer into area 1, and that is going to be made up by selection of out of the red bids that you see in the figure. So the red greenhouse gas bid adders are selected to add up to 110. And this is the constraint that we refer to as the greenhouse gas transfer allocation constraint. And in this particular case, as you can see, the G6 is scheduled for 200 megawatts, and 110 megawatts of that generator at $1 is getting an attribution for the 110 greenhouse gas transfer into area 1. And that's why the marginal greenhouse gas cost in area 1 is $1 set by this generator 6. Something similar happens in area 2, where you have a greenhouse gas transfer of 330 megawatts, and that is made up by the next, by the cheapest green bid, which is G8. We take the whole 200, and then we still need 130. We're going to take that from the next cheaper green bid, which is G4. So G4 gets a attribution of 130 megawatts, and it's marginal for that greenhouse gas transfer, which the price is $4 because that's the bid of G4. So today in EIM, because we only have one greenhouse gas regulation area, California, when we started back in 2014, implementing the greenhouse gas regulation model, we wanted to not have an impact to our ISO LFPs at the time, so we introduced the greenhouse gas, the marginal greenhouse gas component of the LFP to area 0 as a negative component. We structured the greenhouse gas transfer allocation constraint that I described now in such a way so that the marginal component of the LNP appears negative in area 0, and then you have the price differential still between area 0 and California, shows that there is an extra greenhouse gas regulation cost in the LNPs in California. In EDAM, and eventually in EIM as well, now that we have to support multiple greenhouse gas regulation areas, obviously we can't do that. We have to flip this around because now we have multiple greenhouse gas transfers. So we change the polarity in the equation that we use for formulating the greenhouse gas constraint. So now it's formulated as an import constraint, and that has the effect of having the greenhouse gas marginal component of the LNP being 0 in area 0 and positive in area 1 and positive in area 2. So in area 1, that marginal greenhouse gas component of the LNP is $1. It's set as a set of price of the greenhouse gas transfer allocation constraint. And that's why the LNP in area 1 is $71. And similarly in area 2, the marginal greenhouse gas regulation cost is $4, and that's added to the $70 for the BAA LNP, and you get a total of $74. Now, let's go to your question. Obviously, the bids in area 1 do reflect the cost of greenhouse gas regulation for area 1, like the $90 bid for G1. If we have a situation where the marginal resource is, let's say, G1 inside greenhouse gas area 1, the question was, do we double count the marginal cost for greenhouse gas regulation because you have a bid that is marginal setting the LMP, which has a component inside that we don't see, but it's in there. The cost of greenhouse gas regulation is internalizing that $90 bid. And then you have potentially an additional cost, which is the marginal congestion component, the marginal greenhouse gas regulation component of the LMP introduced by a greenhouse gas transfer. So the answer, at least in this simple example, is no. And the reason is the following. If you have G1 being marginal, essentially it's a cheap resource that will be selected to run. In this case, you would not have an import greenhouse gas transfer. It will either be zero or it will be an export if that generator generates more than L1 and the greenhouse gas area 1 is exporting. So whenever you have a zero greenhouse gas transfer or it's an export, you do not have a marginal greenhouse gas component for the LMP. So in that case, you would have a price seen across the grid at $71. You would not have the situation where, okay, it would be $90, which would be the bid of G1 if it was the cheapest generator and would be marginal. So you won't have this duplication of the cost of greenhouse gas regulation. Carla?
Okay, yeah, no, I appreciate that explanation. So is that true in all situations where you will never have the SMAC be based on an energy bid from a resource in a GHG area? And when that happens, you will never have GHG transfers?
Kelly, I can't say in all situations because obviously this is a very simple example that doesn't have transmission congestion. In a situation with one transmission congestion creates a difference in the LFPs because now you have the congestion component. But in general, if you have marginal resources inside the greenhouse gas regulation area, you don't expect the greenhouse gas transfer to be in the input direction. Those marginal resources obviously serve the last increment of demand. Unless you have staggered bids, that it's difficult to show here in this example. If you have staggered bids, in the sense that you get some generation from inside the area to serve some load, then you get a greenhouse gas bid from an external load, so you get some energy from there, so you have some greenhouse gas transfer, but still you need more, and then you go to the next resource inside the area, then you could have a situation where the marginal resource inside the area is an internal generator and sets the price, right? And then you have now a component for the greenhouse gas. And I haven't seen this because I have to, we have to run some examples to see this playing out. But from some theoretical analysis now that we can do, you can have the LMP inside the area 1 having a marginal energy component set by this marginal generator inside the area, and that marginal energy component has some greenhouse gas regulation cost, okay, for the energy that is generated from that generator. And then you have an additional component of the LFP for the cost of the greenhouse gas regulation for the import, for the greenhouse gas transfer. That's not different than today. Today, if you have imports into California, those imports have a greenhouse gas cost assigned. Now, you don't see it separately as a component of the LMP because imports do not have greenhouse gas others. They internalize this into their bid. So you could have a situation where you have an LMP in area 1 that its marginal energy component includes some cost for greenhouse gas regulation for the marginal generator that sets the LMP, and then you have a marginal greenhouse gas cost component that reflects the additional cost of greenhouse gas regulation that applies to the imports into this area.
Okay, no, thank you. And that's the exact scenario that I was going through in my mind, because from a price formation perspective, I guess I'm not quite sure how to interpret the different components because they have, they send out certain price signals. And if you're saying the cost of GHG in an LMP in the GHG area is made up of the LMP GHG component plus some unknown portion of the SMEC, from a price formation perspective, that seems a little odd. But I'll give it some more thought. I did want to raise that just to make sure that is a potential scenario, and wondering if maybe the way to address that would be to have all resources, including those in the GHG area, separate out their energy bid from their GHG bid so we get that transparency from a price signal perspective. But I appreciate you walking through that. I'll give it some more thought, and I won't take up any more time. Thank you.
Thank you, Carly. And one thought that goes along with this.
Hey, George, could you repeat yourself? It's coming in a little choppy.
I'm sorry, maybe my internet connection is not strong here. So I was saying that the selling price on the greenhouse gas transfer, being $1 here for area 1, is a similar effect of congestion, right? So you have price separation between area 1 and area 0, all right? Because area 0 provides energy to area 1 at an additional cost that is not captured in the marginal energy component of the LP. So you may see it as perhaps a duplication of the greenhouse gas regulation, but it's really an effect similar to the congestion you have between areas where there is a limited transfer. Here, the transfer is not limited, but it has a similar effect with the battery. So where we basically have a cost if it's used, right? Because it has a cost behind it, which is the greenhouse gas bid address of the resources that are attributed. So it's not a direct comparison, but it gives you some idea why this cost is in place, because it shows that there is a price difference between area 0 and area 1, and this cost results in what we call greenhouse gas revenue, because we collect on this, similar to the revenue that we collect for congestion. It's a similar effect. So going down this path here and continuing this example, we have revenue that is collected for those greenhouse gas transfers. There is $110 collected on T1, okay, because of this price differential between the $71 in greenhouse gas area 1 and the $70 in area 0, essentially, right? And then there is also a 4 times $330 collected on greenhouse gas transfer T2. So in the resource-specific or dimming approach, the market operator stays neutral by taking this greenhouse gas transfer revenue and distributing it to the attributions that they contribute to it. So for the $110 okay, of transfer T1, the attribution that comes with it is the $110 of G6. So G6 receives an additional payment besides the energy settlement of $200, of 200 megawatts at $70, receives an additional settlement for the 110 megawatts of attribution at $1. And similarly for the greenhouse gas transfer T2, generator G8 receives an additional payment for 200 megawatts of the attribution at $4. Okay, it's a marginal. And generator G4 receives 130 megawatts for its attribution at $4, and that's how the market operator stays neutral in the resource-specific approach. Let's open for questions before we move forward.
Sure, Brenda, I realize there's some on the line.
We can go ahead and unmute Mark Coleman.
Hey, George, it's Rob Campbell at PowerX. Mark had to step out for a sec. Actually, this is just a logistics question for this morning. As much for you as for Anya, is there going to be a chance later this morning to talk a little bit about the model with the spreadsheet? I appreciate, building out this model, and obviously it's a huge job to build out these scenarios. We've been playing with the model a little bit, and this is a great example, kind of a straightforward case. And we're seeing some examples that are turning out kind of differently from the principles that you were walking through yesterday. So I'm just hoping and wanting to confirm there's going to be a chance to walk through this, the actual model with some other scenarios later this morning. That's to you or to
I hope
what the schedule looks like. It seemed like there was a chance in the schedule to do that.
We may not have time to do this by noon today, but if there is interest, we can definitely try to do something about it. Maybe.
Yeah, I think it would be helpful. I mean, this is a great example, and it sort of lays out some sort of the straightforward scenario. We're producing some variations that still get to be quite a bit of kind of unexpected results given the way things were described yesterday. So it would be helpful to have a chance to walk through that, make sure that we all have a common understanding of how it works and that the constraints are implemented sort of the way that you were describing them yesterday. So ideally we get a chance, and I'll just throw that to Anya. I think it would be helpful for everybody to work through some other cases.
Yes, and it's a very simple setup for an example here. So there are several moving parts, but there's not enough options for the optimization to find a solution. So obviously, if you start putting constraints on transfers or restricting the attributions with a greenhouse gas reference, you may get some results that, although they're optimal, they look maybe strange because the optimization model is really stressed to find a solution. It's a very small example. So we may not get representative results of an actual power system solved with this model. I have to say that, and I know what you mean because I played with it myself too.
Yeah, absolutely, and I mean I appreciate it's a huge job and it's an Excel model that's not the same robustness of your larger model. I think the lesson from the EIM process is it's worthwhile kicking the tires from a variety of different angles to make sure that we're not getting surprised by the results. And so I would just encourage that we make sure we walk through that so that we're not ending up with something that's quite a bit different than the straightforward case would suggest.
Right.
Okay, that's great. Thanks. I'll leave to the next question.
Sure.
This is Mark.
Absolutely. Thank you.
Just for one second, George. I think the purpose of these examples are not to be exhaustive of demonstrating all the different scenarios that can play out. Certainly, these are simplified. They don't have a reference or a base or counterfactual schedule. I think these examples are trying to illustrate the comparative approach to the resource specific, to the zonal approach, and then to a variant of the LA or hybrid approach. And I would take a view of it comparatively, not in an absolute sense that these demonstrate all the intricacies or things that can happen. Certainly the spreadsheet or the Excel spreadsheet can do more of those things, but I don't think that's the purpose of this walkthrough today.
No, I appreciate that. I appreciate that.
All right. Brenda, is there another question on the phone? And I also want to open up to questions in the room, but let's take the phone first.
Yes, we do have Lindsay. Lindsay, your line's unmuted. Go ahead.
Hi, George. It's Lindsay Schluckaway from NV Energy. I had really just a quick question. For Generator 8, I see that you've awarded 200 megawatts of GHG, and I'm kind of wondering, this looks more like a solution of where we are currently today and not some of the enhanced proposals that CAISO has proposed to limit the transfer by or limit the GHG award by the 100 megawatt transfer amount. So was there a reason that you left it in at 200, or I don't know. I was just kind of confused by that.
Oh, you're referring to how I structured the greenhouse gas bid address for this example?
No, sorry. For generator
Like for
8,
example,
no. So for generator 8, I see 200 megawatts was awarded, but there's a transfer of 100 megawatts. And I guess from how, and maybe I misunderstood the proposal or the proposed enhancements, but I thought for the resource specific, we were also possibly proposing a limit on the GHG award to the export. Is that not correct?
Yes, it's part of the proposal to limit attributions out of a BAA to the net export. Actually, in the model, I didn't add this constraint because in general, this constraint is non-linear and it's difficult to do it with Excel, but I also wanted to have a simplified example. Incidentally, that is true here because you have a total of attributions being 110 plus 200, 310 megawatts in BAAC, and BAAC is a net exporter for 400 megawatts, so even if I had this constraint enforced, it would be irrelevant. But I know what you're talking about. Normally, you would have, based on that enhancement that we proposed, you would have a constraint saying, since BAAC is a net exporter for 400 megawatts, do not attribute more than 400 megawatts to resources in BAAC. And this is probably the constraint you're referring to, am I right?
It is, yes. Okay, that's helpful. So it would be, so in the proposal, it would be limited to 400 megawatts.
Yes, if we add this constraint, yes. In this example, I didn't do that for the reasons that I explained. I was running very, very close to the limits of what the Excel solver can do.
No, okay, this is very helpful. Thank you.
So just to be clear from that discussion, just to be clear, BCC, even though you didn't enforce that constraint, BCC would not have hit that constraint of a net export constraint on attributable GHG quantities, correct?
That's correct.
Okay.
You have 310 megawatts of attribution, total attribution for 100 megawatt net export. So we didn't hit that constraint. What is perhaps interesting to note here before we move forward is because of the fact that the greenhouse gas areas are not aligned completely with the BAAs, you can have the effect that you can actually see it here in the solution. G4 is in BAA-B, and it gets an attribution for the greenhouse gas area 2, which is a portion of BAA-B. So you can have actually a greenhouse gas transfer into a greenhouse gas regulation area that is within a BAA. And that greenhouse gas transfer could have contributions from resources within the BAA, but outside the greenhouse gas area. You can think here of LDWP as an example, where you have resources outside California that are part of the LDWP balancing authority area. Okay, let's see if we don't have any more questions.
George, I think we might have some more questions. Are there any in the room or online? Looks like we've got some online.
We will go to Petar Restanovic from SGM.
Good morning, George. Excellent work.
Good morning.
As I always say, no good deed goes unpunished. So get ready to receive all the punishment. So in this case, if you use counterfactual, G5 and G6 will be a 200 GHG reference, right?
G5 I assume to be a non-emitting resource, so actually I kind of intentional didn't give it a greenhouse gas bid here because I said that
independent of the G6 is important because load is 400, and these are two cheapest resources in BAC. They will be scheduled at 400, each of them 200. And then if you use reference GAG as 200, then G6 cannot send GAG type of export to any of GAG zones. So the movement will go to G7, and that will imply probably that GAG marginal cost that goes to GAG area 1 will be $2, not $1. So I think that's why it's very important to use the reference counterfactual if you want to calculate correct marginal GAG cost that should be implemented on net import into GAG zones. Now, I have a question about that reference improvement that you made. It looks like by limiting GAG attribution in resource-specific approach, you're limiting attribution to whatever is different between GAG bid max and counterfactual, but you don't guarantee that attribution may happen even if that resource is scheduled below GAG reference. You're just guaranteeing that range cannot be attributed more than that. But you can have a situation where resource is scheduled below GAG reference and is attributed to GAG export to GAG zone.
That is correct. We have considered that fact. And we have seen it actually in practice in EIN. It's possible.
Yeah, so
if a resource is decondemned, yeah.
And the last one, I want to make a point that is showing in this example, but it can be proved mathematically in a very rigorous way, that GAG regulations don't impact LMP prices in non-GAG zone. It's obvious in this example, the 71 and 74 in no way impact LMPs outside of GAG zones. And that was discussed yesterday. The concern was raised that resource-specific approach propagates GAG cost to LMPs outside of non-GAG zones, inside non-GAG zones. And obviously in this example, and again, mathematically can be proved that is not the case. Thank you.
Great,
sorry, Pedro, I didn't follow your last statement.
I said that the GAG cost and regulation do not propagate to LMPs outside of GAG.
Oh, yes.
And this example shows that, and it can be mathematically proved using your mathematical model for resource-specific approach, but making appropriate derivatives and show exactly that you are not propagating GAG cost to LMPs outside of GAG zones.
Yes, that's correct.
All right, George, we've got a question in the room from Paul Nelson.
Jeff Nelson.
Jeff Nelson, sorry.
Wrong Nelson.
Wrong Nelson.
George, good morning, and good morning. It's Jeff Nelson from SCE. Petar just said something that troubled me. I just want to confirm that even in this formulation, the objective function is minimizing the total cost to serve load. We're not trying to minimize cost. We're not doing micro or local cost minimizations such that BAAC's cost is minimized to serve itself. It seemed like something Petar said implied that somehow we should be minimizing the cost locally, not globally. So just confirming, we're still global minimization of total load costs.
Yeah, the only thing that's happening here is besides the standard cost of energy, or it's minimized as part of the objective function, we have an additional cost, which is the cost of greenhouse gas regulation. So those two are co-optimized, and we minimize the total because the objective has both components. So, and this is globally. So we minimize here the energy cost for serving all load everywhere, plus the greenhouse gas regulation cost for serving load in area 1, plus greenhouse gas regulation cost for serving load in area 2. All of this is optimized.
Right. And just for emphasis, there's actually no optimization argument that the cheapest resources need to be dedicated to serving their own local load. That's not part of our optimization. That's not part of any economic philosophy we have. It's sort of a question.
That would not be a market. Yeah, that would not be a market if you have segregation trying to do. Jeff, it's interesting. You had proposals for a balance reserve that contradict your statement, but I'll take it now that you say it.
Okay, I was just a little confused about his argument that the marginal cost should be $2 in BAAC because somehow the counterfactual would say the cheapest resources would serve local load. So I'm going to stop there. I just don't understand the point that was being made. Thank you for clarifying how the optimization is working. Thanks.
Okay, maybe I can explain exactly what was the discussion with respect to the counterfactual. So the counterfactual is an attempt to calculate how the resources in Area 0 would have been scheduled if the greenhouse gas regulation was not in the solution of the model. And then that's what we can call the primer dispatch. And then we want to see greenhouse gas adders on top of that reference. And ideally, we want to have greenhouse gas attributions that are in addition to that reference. For the mechanics of the model, sometimes you may have a situation where you can get a greenhouse gas attribution for a resource that goes below its greenhouse gas reference, which immediately raises concerns that, oh, this is probably a good part of that constitutes secondary dispatch. So all the discussion with respect to the greenhouse gas reference about the secondary dispatch concept. And you have that outcome because we don't dynamically limit the attribution to be always in addition to the greenhouse gas reference, because we had discussions on that. There are some issues with that. So we do this limitation of the attribution outside of the model. We limit the greenhouse gas, the maximum greenhouse gas adder that you can get, attribution that you can get, is limited to the difference between the upper economic limit, the top of your energy bid, which is as much schedule as you can get, and that greenhouse gas reference. So limiting that attribution there, we actually reduce the occurrence of that event that you can have an attribution below the greenhouse gas reference, but we cannot eliminate that possibility. And I think Peter was referring to this particular aspect.
All right, and we have another question from Peter. Could we unmute Petar's line?
Hey, Jeff, it's Petar. Just to follow up on your question. CARB insisted for us when we were designing this to capture resource shuffling and secondary dispatch or leakage, name it any way you want. So what was the goal and the problem raised by CARB is that BAC without market will operate 200-200 for G5 and G6. And then when we put it together in the market, we will start importing to California inexpensive, the least expensive resources and substitute them with more expensive resources, potentially emitting resources, and that emission will not be captured. So CARB wanted to capture atmospheric impact of the market, and that's why we introduced this reference point, GAG, like how BAC will operate if there is no market and not transfer to GAG zones. So optimization is still the whole footprint, but there are constraints put in place to prevent or minimize resource shuffling. And all the discussion is going around that. So I know there is interest of entities in California, like utilities, to get cheapest energy, but then CARB has a problem if resource shuffling results in not capturing GHG emissions.
Okay, I'm going to step in here for a second because I want to use words precisely. So resource shuffling is a defined term in CARB. This is not, they didn't want us to capture resource shuffling. This is not resource shuffling from their definition. It is leakage, it is secondary dispatch, and what we worked with CARB is we wanted to get the entire environmental impacts of the entire dispatch. So I'm not trying to be, I just want to be clear about it. Yes, we do need, and that's why we put in place the mechanism to use the reference and find out what the dispatch is relative to that reference and how much quantity of GHG dispatch we have on that resource. That's what is currently in place in WEAM. That's what creates the residual quantifications that we are calculating and distributing to load serving entities. I'm just trying to make the point that is in the CARB regulation. That is not resource shuffling that we're capturing. We're capturing the entire dispatch effects or the GHG effects of the dispatch. And I know some of you are going, well, why is he saying that? But it's important clarification.
Thank you, Mark. And I want to add to that CARB also has a process by which they calculate residual emissions ex post. So the idea is that if these secondary emission costs are not captured in the optimal solution, then CARB attempts to capture that ex post. Peter, your line is open.
Sorry, George. Let me just disconnect.
Okay. Do we have any more questions on the resource-specific dimming approach?
All right, let's move on. George, are you ready to talk about the zonal approach?
Yes, sure. Let's move to the zonal approach. We use the same setup for the zonal approach, and to have a comparison between the zonal approach results and the results that we saw from the resource-specific dimming approach. In the zonal approach, there are no attributions. There are no greenhouse gas bid others. We still have in the model the concept of the greenhouse gas transfer. That's T1 and T2 there, right? And the optimization will find a solution, an optimal solution for this transfer by assigning a cost to this transfer, what we call a hurdle rate, right? And so that we have a similar example and compare it with the settlement of the previous resource-specific solution, I intentionally selected the hurdle rate for T1 to be $1 and the hurdle rate for T2 to be $4. Okay, so I'm using the same values that were the result of the optimal solution for the resource-specific approach, where these were the marginal greenhouse gas regulation costs for Area 1 and Area 2, so that we have the same settlement for comparison purposes. In general, the hurdle rate for each of the greenhouse gas regulation areas is an exogenous data to the optimization. It's provided as input. So with these values of $1 and $4, the solution is in megawatts exactly the same with the one that we got earlier. So you have obviously again all the generators in Area C. They're scheduled at the maximum capacity of 200 megawatts. So you have a 400 megawatt net export as a BAA net transfer from Area C. 300 goes to Area A and 100 to Area B as before. Your marginal generator is still G3 for Area 0, setting the price to $70 everywhere in Area 0, since we don't have binding scheduling limits on any of the transfers. And you have the hurdle rate of $1 and $4 for the greenhouse gas transfers, which are again clearing at 110 megawatts for tier 1 and 330 megawatts for tier 2, because you want to serve the load there at a price that is less expensive than the local generator, right? They impose a $1 differential for area 1 and a $4 differential for area 2 as the marginal greenhouse gas regulation cost in this area. So again, area 1 has a LMP of $71 and area 2 has an LMP for $74. The settlement is a little bit different here in the zonal approach. So we engineered the solution for this zonal approach example to have the same solution, essentially, with the resource-specific example that we saw earlier, so that we have some comparison. In general, those two methods will give you complete results, of course. In the zonal approach, there is no dimming, so you see that there are no greenhouse gas attributions to any of the generators in area 0, and you don't need that because there is no settlement with generators in area 0. There are no greenhouse gas attributions and no settlement or payment for these resources. Instead, the market operator still collects greenhouse gas transfer revenue of $110 for the transfer to area 1 and 4 times 330 for the transfer to area 2. Now, for the market operator to stay neutral, the market operator has to distribute that revenue. So $110 will be distributed to area 1. That distribution could go to load serving entities in area 1, or, in a simpler way for the market operator is to give that revenue to the regulator for area 1, which can then in turn, based on the regulation, they can retire instruments for the load serving entities in area 1. That will result in an easier solution for the market operator because it doesn't have to track LSCs and load migration issues and all of that. It doesn't matter what the outcome is ultimately going to be. The fact of the matter is that whatever the market operator collects as greenhouse gas transfer revenue for its greenhouse gas regulation area, it distributes that to that area eventually. So that maintains the revenue neutrality. So the zonal approach has a different way for calculating the optimal solution, okay? And it has a different settlement. And let me open up to, before I open up the questions, I want to mention here that in the presentations yesterday and the discussion so far, there has been a notion that in the zonal approach, you have resource-specific attribution, resource-specific transfers and non-resource-specific, unspecified transfers. For me, when I set up these examples, and always, when you get to the point of actually generating examples for an approach, then you find out what you can do and what you cannot do. In the model for the zonal approach, I cannot have those two at the same time. There can only be a single greenhouse gas transfer to a greenhouse gas area, and you can give a hurdle rate for that. There is no mechanism in the model to have choices or multiple choices, like having some transfer being specified, some transfer being unspecified. The model cannot see the distinction between those two. If you really want to distinguish between these, you have to go all the way to resource-specific attributions, because then when you have resource-specific, you can say this resource is a specified importer, or this resource is an unspecified importer. So then you can do that distinction, but then it becomes a resource-specific approach. So for me, the zonal approach, the way that I can see it being possible to be implemented, it all comes down to being unspecified. Essentially, the greenhouse gas transfer here, let's say T2, is an unspecified import. We don't know what resource is behind it. The model doesn't know, doesn't have an attribution to resources, so it's an unspecified import. If you have imports from non-EWBAAs, that's a different story. Those could be specified or unspecified. But if you have imports within the EDAM market footprint from area 0 to any greenhouse gas regulation area, that can only be unspecified in my view, the way I see how this can be implemented. So I thought I should make that comment here. Let's open for questions.
Any questions in the room on the zonal overview? All right, I'm not seeing any in the room. George, are you ready to move on to the LEDWP proposal?
Just one moment. There is another thing I want to mention here, that intentionally in these examples, and for the simplicity of it, I did not consider transfers between greenhouse gas areas. So you could have the model represent transfers from area 1 to area 2, or from area 2 to area 1. In the resource-specific approach, you can do it. You can have greenhouse gas bid address for G2 for area 1 and greenhouse gas bid address for G1 for area 2. It wouldn't make a difference in this particular example because those resources are too expensive to be selected. Anyway, they're not even going to run. But in general, you can set up the problem to have transfers between greenhouse gas regulation areas. So I didn't set up this in this example. For the zonal approach, obviously there's no dimming, so you don't have to do anything like that, but there's no way to separate where the transfer is coming from. For example, if you have, let's say, the T2 transfer from area 0 to area 2, some of it could be coming from G1 if it's running, but the model cannot see that and cannot identify it, so it's really a transfer from area, it's a transfer into area 2. You can see it as that. Okay, so with this comment, we can move to what we call the hybrid approach.
Quick question on
Sure.
the zonal. George, hi, it's Jeff Nelson from SCE again. This was, like you said, sort of engineered to have exactly the same hurdle rates to sort of get you to the exact same solution. Just to make sure I understand the impact of hurdle rates here. If instead of the $1 and $4, the hurdle rate was $25 for both of these, that would change the dispatch, correct? You would have G1 ramping up because if the marginal cost is 70 and you add $25 on it, that makes it look like a $95 unit outside, and there's a $90 unit inside. So that would actually change the dispatch where G1 is now generating, and I guess G3 is backing down. Do I just sort of have that right on how a $25 hurdle rate would affect GHG Area 1?
You are correct. If you have such a high hurdle rate for Area 1, the optimization model will end up having a schedule for G1 instead of the transfer from G3 or G4 or anywhere else, because the differential is too high and the economics will prevent a greenhouse gas transfer into Area 1. It will be cheaper to serve L1 from G1.
And that's sort of where people are concerned of that impact of not letting G3 sell, sort of concerns about the hurdle rates creating potentially something that could be classified as a discriminatory treatment against G3.
I will not comment on the discriminatory nature, but I'm just going to comment from a mathematical perspective that, as I said, the hurdle rate in the zonal approach is an exogenous input, whereas in the resource-specific approach, it's actually calculated optimally by the model. So you can say that, in the zonal approach, you have to come up with a hurdle rate that makes sense, and it may never be the one that you would have optimally calculated by the model in the resource-specific approach. If that's that I can say. Now, what is discriminatory or not, I'll let other people opine.
Okay, this one will be a little less charged, hopefully. So here, there's sort of the $1 that you say that gets collected. Back to your example, exactly as structured here. In the earlier conversation, there was still a question on whether there was, Mark, please let me use the right words, secondary dispatch that needed to be accounted for in addition to the $1. In this exact structure you set up here, is there still a secondary dispatch issue?
Yes.
Yeah, so even with this approach, there's still a secondary dispatch concern.
Yes, because every time you have a greenhouse gas transfer that is different than zero, that means that some energy in area 0 is directed to area 1, so there is some backfilling that will happen in area 0. The idea in the zonal approach is that you set the hurdle rate, whatever is here shown as $1 or $4, so that you try to capture the cost for that secondary dispatch. Of course, it's easier said than done, but that's the idea. If you have the proper hurdle rate that captures the secondary dispatch, then you can say that your optimal solution reflects the cost of secondary dispatch. Or you can have some different approach where you try to capture just the specified rate, and you leave to the regulator like CARB, for example, that has an ex post process for capturing the residual emission cost. So either way, you can do it.
Okay, so I'm just going to summarize the secondary dispatch. The zonal approach does not eliminate the concern of secondary dispatch, only to the extent that you precisely calibrate the hurdle rate. Have you addressed the secondary dispatch under the zonal approach?
Right, that's my opinion. I think this is the understanding that the hurdle rate captures the effect of the secondary dispatch. There's always secondary dispatch.
Okay, I just think that there's an impression out there that the zonal approach eliminates the dispatch question. It doesn't, and I just wanted to get clarity there.
It does.
Okay, thank you.
You're correct. It does not.
Thanks, Jeff. Looks like we've got some callers online. Could we unmute Dan Williams' line?
Hi, thanks. This is Dan Williams from Customized Energy Solutions. I may just want to cede the time to whoever else is on the line, but I just want to make sure that I heard George correctly. Is it that you can't fully model the zonal approach in your simplified solver, or that you can't implement the zonal approach at all?
Okay, let me repeat what I said very clearly, make sure that is understood. I cannot model this duality of having resource-specific or specified importers and unspecified importers when the model always sees essentially one greenhouse gas transfer. So whatever hurdle rate you give, that's the one that will be used. If you attempt to have two transfers, one saying it's an specified rate, the other is an unspecified rate, guess what the model will do? Will use the one that has a lower cost and won't use the other. So there is not enough information in the zonal approach to actually differentiate between specified and unspecified importers unless you go and pull that all the way to the resources and have dimming. Then, depending on whether you classify the resource to be a specified importer or an unspecified importer, now you can do that, but that is the resource-specific dimming approach, not anymore the zonal approach. So that's in that respect, I'm saying I can't have the model support both these concepts of specified and unspecified imports. You can only have one.
And when you're saying the model, are you talking about your simplified solver here, or just full stop what you could do with the full model in production?
The solver really reflects how you can implement this. So if I can find a way to do it in the solver, I don't think it can be done. The model just doesn't have enough information. I'm sorry, I'll repeat it. The model in general, not only the solver, the model that you have for the zonal approach in general, it doesn't have enough information to distinguish between specified and unspecified inputs because you don't have resource-specific attributes.
I think all you're saying, George, is that if you go down the zonal road, you can't answer the question anymore about what resources did what and what load they were serving. You can't you can't answer that question anymore because you don't have the detail, that information to answer that question. That's what you're saying.
Yes.
Okay.
Okay, that doesn't seem to track with how the zonal approach was presented, but I'll leave it to others to go deeper on that.
All right, we've got a comment from Mary in the room. Go ahead, Mary.
Well, hold on a second. I want to follow up on that because I think the zonal approach is explicitly getting away from trying to deem a resource, and therefore it's never asked to answer that question about what resource is supporting those transfers. And it's for that reason you don't have the ability to say a resource is the complying entity. You don't have that information. You can't make that determination in the zonal approach.
That's correct. You can make that determination only for imports into a greenhouse gas regulation area from non-EDM BAAs. They're not part of transfers. They are because it is a distinct system resources, and you can classify them and specify them, and you can use the right rate if you want, or you can let them internalize that in their base. But in the general solution from area 0, greenhouse gas transfer to a greenhouse gas regulation area, you don't have the resource-specific information of what contributes to the transfer, so you can't make such a distinction.
Right. So you no longer have the resource-specific adders. Those are not applied to the optimization. Without those adders, you can't make that distinction. You're just applying the GHG effects through that hurdle rate, not through any resource-specific adders.
Correct.
Okay.
All right, let's go to Mary in the room.
Thanks. I think some of this clarification already got made, but I was just going to make a comment that the zonal approach recognizes the challenges and difficulty with making that determination accurately, and so avoids the need to do so. So I think it is not necessarily characterized as sort of ignoring available information, but recognizing how challenging it is to accurately link resources and loads in this context.
Yeah. Doesn't even try. Yeah.
All right. Any other comments or questions before we move to LEDWP's proposal in the room? I'm not seeing any online. All right, George, I'll turn it back to you.
So before you do that,
thank you, Anya.
This is our interpretation of the LEDWP. I don't think we've completely reconciled. This is their approach. We're calling it hybrid, but I think it's our interpretation of the LEDWP approach.
Thank you, Mark. Yes, I was going to say that this is our view of the hybrid approach, and I may have taken the LA approach all the way to the extreme here, putting it on steroids, and I'll explain. So in the hybrid approach, what we want to do is we want to retain the exact calculation that we have in the resource-specific approach with beaming that gives us the ability to accurately represent the greenhouse gas regulation cost for each resource that gets a deeming, all right, so that this will lead to an optimal solution with an accurate marginal greenhouse gas regulation cost, okay? Yet, we don't want to follow up with the settlement of the resource-specific approach, so the deeming, the greenhouse gas attributions, are only used as a tool to obtain the optimal solution. Then we turn around and throw them away. They don't mean anything anymore. We do the settlement according to the zonal approach. So that's why we call it a hybrid approach. So it calculates the optimal solution using the resource-specific, essentially, deeming approach, but then it continues with the settlement for the zonal approach. So as Stuart mentioned yesterday, this is an attempt to combine the strengths of both proposals, right? The accuracy for the optimal solution calculation with the simplicity of the settlement for the zonal approach, where of course the entity that is regulated is load, not the external generators that contribute to the transfers. So we have here the same example to solve, but now with a hybrid approach, since there is no settlement for generators that will get greenhouse gas attribution, because the greenhouse gas attribution is only a tool for getting the solution. In the first phase of the hybrid approach, where we're doing the resource-specific solution, we want to go all out. We won't have any kind of limitation for attribution. So we want to get the absolutely most efficient, optimal solution for the entire grid. So here, we don't have resources or participants submitting greenhouse gas bids. None of that. We do that all internally. So give me a click, Anya. So here, basically, we assign, the market operator internally assigns a greenhouse gas bid for every resource in area 0, okay? Even G5 didn't have a bid so far in the resource-specific approach. We'll be given a bid, a greenhouse gas bid adder for both greenhouse gas areas. So you have two greenhouse gas bid adders, so red and green, for every resource in area 0, all right? And that greenhouse gas bid adder reflects the cost of greenhouse gas regulation for that resource, which internalizes the emission rate as it's registered, master file, times the carbon cost for its area. For simplicity here, I show that both areas have the same carbon cost. So you see that the bids, the red and green are the same, all right? So G5 is at $0, general emitting resource, and the rest are the same as we used before. But now you have full participation. This is the full dimming approach. So we go all out here. And we also don't use a greenhouse gas reference because we don't care for secondary dispatch. We're doing a global optimization. If there is secondary dispatch, we let the regulator address that externally. We don't let that pollute the optimal solution. So with this kind of attitude, the hybrid approach will get the absolutely most efficient, optimal solution, both for energy and for greenhouse gas regulation cost over the entire grid. And that's what you see here as the solution. The megawatts are still the same for the resources. Obviously, all the resources in area C are scheduled at their maximum because they're very efficient. You still have a 400 megawatt net export transfer from the AAC. You still have greenhouse gas transfers of 110 megawatts into area 1, 330 megawatts into area 2. Generator G3 is still the marginal resource in area 0, setting the price at $70. But what is different in this solution is the cost of greenhouse gas regulation. Why is it different? Because now we have full dimming, full participation from external resources. So you get a more efficient solution. As you can see, the transfer T1 of 110 is made by G6, which also contributes the remaining of its capacity of its schedule of 90 megawatts to T2. Then you get also 200 megawatts for T2 from G5. And then at the end, you have to get an additional 40 megawatts to make up the transfers from G7, which bids a greenhouse gas bid at $2. So you have both transfers clearing at $2. In the resource-specific solution, we had T1 clearing at $1 and T2 clearing at $4. This is a more efficient solution here, where both transfers clear at $2. You have a lower cost for greenhouse gas regulation, of course, lower cost overall. So this is the objective and advantage, I can say, for the hybrid approach, that disregards all the red tape regarding what resource is willing to participate in the greenhouse gas regulation. This doesn't matter. It's not going to be responsible for reporting. We won't have any reporting requirements. We don't care about secondary dispatch. We leave that to the regulator to address ex post. So the only thing that we care for is finding the absolutely best optimal solution, both in energy and greenhouse cost regulation. And that's what this method does. And it does it in a way that we don't impose infrastructure burden. There is no bids that are coming in through the system, validating whatever. We do it all internally. We find the solution, and then we turn around, we say, okay, now we forget all the attributions. We don't care for the attributions. They don't mean anything anymore. They were just a tool for finding a solution. and we proceed with the settlement for the zonal approach. What happens here? The market operator collects $2 for 110 megawatt transfer into area 1. Okay, that's $220 for area 1, and then collects $2 for 330 megawatts into area 2, another $660. And this is distributed either to the LSCs of each area or to the regulator for each area, and the market operator stays neutral. And this is the end of the story. Now, the LA proposal had an ex-post calculation of a weighted average price for the greenhouse gas cost, not the marginal cost that we saw here at $2. We will have some more discussion with LA on this. I do believe that it's necessary. At the end, you'll end up having these values that are the marginal costs that are used in settlements. We don't want to have additional neutrality with any difference in the price, that it will anyway be absorbed by the same entities that this payment is made, so it doesn't make any difference. So we'll have some more discussion with LA on that particular aspect of the proposal. But other than that, I think this example illustrates how the hybrid approach would work. So let's open for questions here.
All right, it looks like we have one from Callie. Could we unmute Callie's line?
Hey, George, it's Callie Wells with WPTF again. Thank you again for putting this together. I think this really helped solidify in my mind the discussion yesterday on this hybrid approach. So I know you said this is kind of one extreme, and there were some options that were discussed or variations that were discussed yesterday afternoon. But a couple quick clarifying questions on this example. So I know in this approach, the CAISO would be the one inserting the bid adders. And in this example, you have the same bid adder for both GHG areas. So for example, G5 has 0 for both, G6 has 1 for both. Was that intentional, or do you envision in reality that there could be a different bid adder to each of the GHG areas depending on whatever prevailing GHG price is in both of those programs, especially at the beginning when they're not linked?
Mm-hmm. Yeah, that's a great question, Callie, and really it depends on the carbon cost that each greenhouse gas area has. So I assume here that the carbon cost is the same for both areas, but if it's different, which would probably suggest that the programs are not linked, then you would have different bids for the emitting resources, because essentially the greenhouse gas bid here is calculated as the product of the emission rate and the carbon cost, right? So with different carbon costs, you will end up having different greenhouse gas bids for the two areas. So for the purpose of this example, I just consider the same carbon cost for simplicity.
Okay, that's what I assumed was the case, but always like to confirm. And then would you also consider from day one, or maybe at some point in time, allowing or putting in a bid adder for resources in GHG Area 1 to go to GHG Area 2?
Yes, this may be an important feature if the programs are not linked, and with the assumption that you have, perhaps a surplus of non-emitting or low-emitting supply in one area that could actually contribute to the greenhouse gas transfers of the other area. You could have greenhouse gas bid adders for resources in Area 1 for Area 2 and vice versa. It's an additional element of the model that can be accommodated. There are also other elements that can be accommodated here. I didn't bring them in this example, like the concept of the greenhouse gas pseudo tie. That can also be incorporated.
Okay, I appreciate that. My last question here is, with this approach, you mentioned that the market optimization will find the truly least cost dispatch for globally. And to me, what that says is, and I think your example shows it, is it's going to, because it is a least cost dispatch, pick the cleanest and cheapest resources first to serve load in the GHG areas. And I'm wondering at some point in time if we go down this path, if that's a policy question that we need, or a policy discussion we need to have, if that makes sense. Or one of the variations that was discussed yesterday was maybe we do need some sort of baseline or reference point in here to get a more accurate GHG price signal. I understand that the deeming part of this isn't relevant for settlement or obligation purposes, but having that reference point in there does and will have an impact on that marginal GHG cost, so the $2 in this example. So just wanted to throw that out there. I think that if we continue exploring this approach, that's something that needs to be discussed at some point in time. So thank you.
That's right, but let me correct. I didn't say the true optimal. I said the most efficient optimal solution. Whether it's true or not, that's at the eyes of the beholder, as you mentioned. So yes, if this is the rock bottom that you can reach, right? Adding any constraints or any limitations that you deem to necessary because of policy considerations obviously will result in a higher cost solution. So I'm just showing here the least possible cost that you can get. And it's not for serving load in area 1 or area 2. Again, it's the same answer I gave to Jeff Nelson. We're optimizing the entire grid. So we're minimizing all the cost for energy plus all the cost for greenhouse gas regulation, and they're all co-optimized so you reach the absolute minimum of that combined cost.
Yeah, no, I appreciate that. But again, this comes from a price formation, price signal perspective. You know, $2, is that an accurate price signal that we should be sending out? And again, I think that's a policy question or discussion that would need to take place, because that would, you know, do we want to include some sort of reference point to improve the accuracy of that price signal? So thank you.
All right, thanks, Kelly. Let's go next to Laura. Laura, do you want to unmute yourself?
Hi, Laura Trelease from the Energy Authority. I had a clarifying question on Generator 5. A couple slides ago when you were going through the resource-specific approach, Generator 5 was a resource that opted to not provide a GHG adder and not be deemed delivered to a GHG regulated area. So in this example on slide 116, is Generator 5 a non-emitting resource, or is it a resource that opted out but is but the market operator is setting their bid adder at 0 because they
that's a good
out.
question. Yeah, so in the resource-specific approach, we have voluntary bids submission for greenhouse gas bid adders, and the example assumed that generator G5, which is a non-emitting resource, did not wish to be exposed to greenhouse gas regulation of either area, so it didn't submit a greenhouse gas bid adder. And that was the solution of the resource-specific approach. In the hybrid approach, no resource is exposed to any greenhouse gas regulation because they're not going to get a deeming and they're not going to get a reporting requirement anyway. So the market operator inserts a bid even for this non-emitting G5 resource for the purpose of finding the least cost optimal solution for the entire grid without, of course, imposing any reporting requirements to G5. So no harm is done, no foul.
Okay, thank you for that clarification.
Thank you, Laura. Let's move next to Rachel. Rachel, go ahead. It looks like Rachel may have taken her hand down. Oh, go ahead, Rachel.
I was too quick to lower my hand. This is Rachel Gold at CARB. I have a clarifying question on both the hybrid approach and the zonal approach. George, based on what you were explaining, could you explain what happens under those resource-specific pathways in these two approaches? How are those megawatt hours that might come in under the resource-specific pathways disaggregated from the total megawatt hours that are flowing to the GHG zones. Or am I missing something here? I'm trying to understand the relationship, the overall picture.
Can I clarify the question? You're asking the question if a resource, like we just talked about G5, wanted to say it was a pseudotide for GHG purposes, and it's actually in a GH area 1, you're saying how would that transfer be excluded from the rest of the transfer? Is that the question you're asking?
Or would it? Or like how should we be like thinking about how that would work? Because I think I'm just missing that piece.
Yeah, I think the answer is, and George, you can clarify if I'm wrong, if that G5 were to satisfy the criteria for being a pseudotide GHG resource to GHG area 1, effectively it would move G5 into GHG area 1, and it would not be contributing to the transfer anymore between GHG area 0 and 1. Is that correct?
That is correct, Mark. If it's pseudotide to area 1, it will be an area 1 resource, so it will get the $72 LMP, and you wouldn't even have a transfer of 110 megawatts here for area 1, since that will be generated internally. So you'll have a different solution. G5 will be producing, actually you'll have exporting from area 1 because G5 has a 200 megawatts, the load is 110, so you actually have an export of 90 megawatts from area 1 in this case, and there is no greenhouse gas transfer cost. So the greenhouse gas component in area 1 will be 0. Okay, so you'll have $70 for area 1 as well. It changes the solution.
Okay, I'm going to have to wrap my head around that a little bit more, but thank you.
Thank you, Rachel. Let's move next to Dan Williams.
Hey, George. Dan Williams again from Customized Energy Solutions. The question that Carb just asked is really what I was trying to get to in my question earlier on the zonal approach, and that's just that there was a discussion yesterday on the resource-specific pathway, and I didn't see that represented at all in your example. And that was what I thought you were saying couldn't be done, but basically from what I heard in the answer just to Carb just now is just that you sort of ignored that in the example because you would just consider it as being within the GHG area that the source-specific pathway would have identified the relationship with.
Yes, Dan, and as I mentioned yesterday, along with the concept of the greenhouse gas transfer of, let's say, G5 into area 1, we have to set some rules around it so that the result makes sense. We also have to have the requirement for G5 to actually pseudotide into BAA, so that G5 contributes to BAA's resource efficiency evaluation and BAA's power balance constraint. So that part has to also happen for having a reasonable outcome. It's not just accounting that would transfer resource to a greenhouse gas regulation area, because we're actually solving a full network, so it has to make sense. You have to actually have a real pseudotie of G5 into BAA for that to make sense.
Okay, I thought there had been some different discussions there, but I'll leave it. I think I understand now what you're saying with regard to the model. Thanks.
Thanks, Dan. Let's move next to Mark Coleman. Go ahead, Mark.
Hi there, George. You still got Rob Campbell. I think it's worthwhile, or I guess I would suggest maybe there's an opportunity to walk through some of these approaches, and we'd be happy to bring some examples forward in terms of characterizing the zonal with how the resource-specific component would work with the zonal. So that's one thing I want to throw out is, I don't know if it's on the schedule to do anything like that where we could essentially take your model and just walk through some examples of how the zonal might fit into this construct? That's the first one. The second, that's just kind of a suggestion for Anya. The second is, I'd love to hear from LA about whether or not they think this properly represents their approach. I know that you guys have put this together, but I'd like to hear whether or not this fits. And I guess my third question would be, is there a scenario where if you reduce the transmission or put a transmission constraint on the exports from BAC, and that you didn't have the carbon prices be linearly stacked, that you would actually change the dispatch in G5, G6, and G7 and in G8 when you've optimized with the greenhouse gas price?
Yes, it's possible. Actually, in the spreadsheet that we have released, there are solutions there for more complicated examples where we have put scheduling limits on those transfers. I don't remember if it was 100 megawatts or 50 megawatts. So that changes the solution dramatically, actually, because those transfers are going to be binding. So now you have price separation between the BAAs. So it's not $70 everywhere in area 0. You have price separation. C is in a different price than BAAs A and B. And you can see that in that example. So indeed, if we have constraints on the transfers, you have a different solution that actually shows more variety in terms of the LMPs.
Okay.
And we didn't show here the example for simplicity, but if you go through the Excel, you'll find examples that show that.
Okay, I appreciate that. So we'll have a look. So what I'm hearing is if there was transmission constraints, depending on the bid adder, you could vary that price in BAAC. Okay, we'll have one. Okay, thank you.
All right, and thanks. That's a good segue to Stuart Kelly in the room. Go ahead, Stuart.
Stuart Kelly, LA. Yeah, this is one bookend. I think the other bookend would be where you maintain the voluntary aspect of bidding in and you use that to set the marginal cost of GHG. And then the other component would be, as Kali mentioned earlier, potentially using a reference point to, some would argue get a better solution. So there's those components. And then George, the other aspect I would suggest is you can still, for source specific, still maintain a self-schedule approach to this and be a price taker. There's the Sudatai option, obviously, where you could leverage maybe excess renewable generation and Sudatai that into the GHG area. But you could also potentially self-schedule, be a price taker. In an ideal world, have a perfect hedge, but exclude that from the pool of resources. So there's some bookends on the approaches. I think as George is getting in with the all-in approach to get the lowest possible market cost.
Thanks, Stuart. Thanks, Stuart. Yes.
Let's move next to Alva Svoboda. Go ahead, Alva.
Can you hear me?
Yes, loud and clear.
Hi. Great. This is Alvis Svoboda at PG&E. Actually, this is really a follow-up on what Stuart just had raised. It seems to me that the two big issues with the bookend that George has defined here is one, that the CAISO has to come up with a credible daily varying or potentially daily varying GHG cost, which is meaningful given the nature of GHG constraints, which are not on a daily basis. And the other is the fact that you're going to have to mix a critical element in the bids being constructed by CAISO on a daily basis with the fact that the market participants can change their bids with respect to those numbers. So I think those are hazards with this bookend. I'm not a great believer in ultimate efficiency, but I think Stuart actually addressed some of what I was going to point out as hazards in this approach, because I think if you did go to a more voluntary approach, at least you wouldn't have those risks in this. So thank you very much, George, for these fantastic examples. I was at sea almost all yesterday, and today I'm finally getting the hang of some of this stuff. So thank you.
Yeah. I just want to reinforce, Alva, that there are bookends here, and folks should consider the bookends to maybe arrive at a solution that they're more comfortable with. But I think it's good in George's example to show the extreme, but you could go back to something that's more aligned to what we discussed and resource specific, as I say, maintain that reference point and also maintain the ability to take out source specific. Some folks may believe that's a more optimal solution, but just really important, there are bookends, and hopefully we can cover the bookends in the straw proposal that comes out.
I agree. And I think the bookend gives us a sense of what the hazards of the bookend are, which then gives you a sense of how to move back towards something that might be more along the lines of the current market design.
Thank you, Alva. There's something that you said yesterday, Stuart, in your presentation that, in a solution here, in an approach where the generator in area 0 does not receive any payment, as it is in the resource-specific approach with the deeming, there is a danger or risk for having external generators in area 0 voluntarily submitting greenhouse gas bid others. So that doesn't make much sense to me as well, because if you're not getting a payment, so your bid is meaningless. Why would you influence the optimal solution with whether you submit a bid or not and how much that bid is going to be? That's why the approach that I outlined here in the example has the market operator putting the bid. Because if there is no settlement, we don't trust what bids participants are going to put, and we don't want them to influence the outcome, right? So
I completely agree, George. I don't believe that the generator in the non-GHG zone under any circumstances with this approach should be submitting the bid. There is no incentive to get it correct. So to Alva's point, and that's one of the discussion points. How do you set that carbon cost? There is some precedent with what we do with stuff in the gas market. So whatever, you could take the secondary market price from the day before, or some such an approach. You could, have the average of auction prices, or even, I think some considerations should be done of having the agencies, set that carbon cost, because that then creates a path for linkage. And if there's consistency with the carbon cost, as we said yesterday, that truly balances out the full footprint. That wouldn't stop each area having ultimately a different carbon cost, but that could be solved in the back end. So there's a lot of considerations that go into this, but we're just trying to work, instead of putting one single approach forward, we just want the approach covered in the straw proposal and some options where folks can weigh the pros and cons.
Thank you, Stuart. Could we get
Am I still unmuted?
Go ahead, Alva.
I just wanted to make one point, which is just that I think that was a well taken point by both George and Stuart, but it is possible for market participants to change the residual bid to essentially subvert everything you're saying. So if they gain an advantage, and unless you're going to basically say that these values are not publicly known, which would be even, in my mind, would be even worse. I think they should be publicly known before the market. Then market participants can essentially adjust their own bids to have exactly the same effect they would have if they were able to bid those values. So I don't think that's necessarily correct to believe that they're not going to be able to have some effect on the solution to their advantage.
And I believe that's the case, Alva. I agree with you there. There's that potential. At the same time, though, some may argue that makes up for the lost revenue in the non-GHG zone that some parties are enjoying today, even though they don't have a GHG policy obligation.
I'll have to think about that one. Thank you. Thank you, Stuart.
Thank you, Stuart. And thank you, Alva. Could we get a mic up to Claire in the room? Sorry.
You hear me? There we go. Claire Brydenich, WPTF. I just want to make sure I'm understanding something correctly. So I'm not sure if this is a question directed to George or if it's a question for Stuart or both. But if I'm understanding correctly, comparing the hybrid to the zonal, resources that are located in greenhouse gas area 0, there would be a much smaller subset of those resources under a hybrid approach that could be considered to serve load in the greenhouse gas area on a resource specific basis. And if I've heard what LA has said correctly, it would only be those resources that are actually pseudo-tied to either greenhouse gas area 1 or greenhouse gas area 2 that would actually be resource specific and then effectively receive LMP in the greenhouse gas area. So that's clarification 1. Whereas under the zonal approach, we're thinking that, there are other visions for how resources might be considered to serve the greenhouse gas areas. If that is in fact the case, that hybrid approach has less resource specific attribution to the greenhouse gas area, and we think about a hypothetical where the zonal would and the hybrid have, let's say, the same greenhouse gas price that's used in optimization, either as a hurdle or imputed by the market operator for the hybrid approach. Same price, same volume of transfer. Payment then by load in the greenhouse gas area would be the same, right? Because they're seeing the same marginal greenhouse gas cost, but the rebate would be different. Is that correct? Because less of that value actually goes to generation outside the greenhouse gas area, the carbon component of the payment. Then it suggests to me that the payment back to load for the greenhouse gas credit is greater under the hybrid approach than the zonal. Am I understanding that correctly, or did I miss something?
I think.
Go ahead, George.
I think it's the other way around, right? The hybrid approach, the way we lay out here, you have the maximum dimming effect. So you have all possibilities for resources in area 0 to get an attribution. Under the resource-specific approach, there are limitations. There are limitations because of the availability of bids. Maybe some participants do not bid, or they don't bid all the capacity, only a portion of it. We have limitations because of the use of a greenhouse gas reference that limits the attributions. We may have limitations due to other constraints that are introduced in the resource-specific approach. So the resource-specific approach will have, in general, less opportunities to dim resources and schedule greenhouse gas transfers. So the cost is expected to be higher with all these constraints. The hybrid approach really cuts through all that and gives you the maximum dimming possible, so you have the lowest possible cost. The zonal approach really can be anywhere because it really depends what you are going to use for the hurdle rate. So you can describe the zonal approach similar to the hybrid approach, that every resource out there in area 0 gets a full greenhouse gas bid, but you put that bid at the hurdle rate. And then you get the same result, the same output with the zonal approach as you're going to get in the resource-specific approach with the hurdle rate for the bids. So it can be anywhere depending on what is the price that you're going to use for the hurdle rate. So it's really difficult to draw conclusions in general, other than what I said, that the resource-specific approach, just by the fact that it has constraints in limiting the attribution, it is expected to result in higher regulation cost and lower volume for greenhouse gas transfers than the hybrid approach.
Very similar.
Yeah. If I could just follow up. I may have confused you with my question. I guess what I'm just really trying to get clear in my mind the difference between zonal and hybrid. And to put it another way, I think I'm understanding that zonal as it's envisioned, has more opportunity for resources in the greenhouse gas area to be basically attributed to the greenhouse gas area on a resource specific basis than the hybrid approach would. I guess that's basically the nut I'm trying to understand.
That's not correct all the time. It really depends on the hurdle rate. Let's go to this example, for example, right? You see the result for the hybrid approach where we're using exact greenhouse gas bid adders at whatever is the resource cost for the greenhouse gas regulation. That's going to be subject to if we had the resource specific approach in place, but we don't have that. We just use the attribution as a mechanism to find a solution. You can make this the zonal approach by changing all these bids, and instead of having all these $0, $1, $2, you just put all these bids at the hurdle rate. So depends on the hurdle rate. If your hurdle rate is high, all right. Let me start with low. If your hurdle rate is low, all of these are going to clear. The same way like in the hybrid approach. So you have a similar outcome. If your hurdle rate is high, maybe some of them are not going to clear because they're just not economic for serving load in the greenhouse gas area if you put a high hurdle rate. So it really depends on the hurdle rate that you're going to use. And that goes back to the discussion that we had earlier with Jeff Nelson, that the hurdle rate and how you set it, it's really critical in the zonal approach. Can really affect the optimal solution. So it depends on that.
I think the question's a little confusing because I think you're asking, would there be more attribution, resource-specific attribution? I think what you're asking is, would there be an incentive for a resource in the non-GHG area to go resource-specific and move itself into the GHG region, which is different than attribution, because the zonal and the hybrid approach don't have any attribution at all.
No, I mean, we're talking around language. We're not. I'm not talking about deeming, but I mean, zonal envisions that resources that are physically located outside the greenhouse gas area can be considered to be within the greenhouse gas area under certain conditions. And the conditions I've heard most often are that would be transmission. There may be other conditions that allow a resource to effectively be treated as it's in the zone and thus have a resource specific bid adder and receive LMP that reflects that zone. As I understand it, for hybrid, there is still a little bit of an opportunity, but it would require that the resource that is physically located outside the state barrier boundary have a pseudo tie. So there'd be less avenues for resources to basically be considered as within the greenhouse gas area. That's what I'm trying to understand.
I think that's one bookend, and let's turn it over to Stuart.
That, as Anya says, that's one bookend, but there's also the opportunity explained earlier to do a self-schedule as a permutation of this particular option. So I wouldn't say the statement that you made is correct. It depends on what permutation we have of this particular proposal.
Okay, this has been a great dialogue. We've left George negative time to go over the model itself, but I will flag we're looking at hosting a public session, and dates we're exploring are either, sorry, just had this up, either the 3rd or the 8th. So we'll have a public notice on when we'll provide that, that overview of the tool itself. Let's go ahead and take a 10-minute break. So please come back by 10:17, and we'll turn things over to James to review GHG settlements. Thanks so much.
Thank you, George, for accommodating the schedule today. So round of applause for George. Thanks, everyone. All right, we'll be starting back up in about 2 minutes. About 2 minutes. All right, I think we're about ready to get started for our last session. This will be our last session before lunch.
Yeah. The diagrams line, but they don't match perfectly. But I did some.
We'll give it 1 more minute, Anya, for people to reassemble.
All right, so it looks like we're still gathering in the room, but for folks online, we're going to go ahead and get started. James Lynn is going to give an overview of settlements for greenhouse gas accounting, looking at the various approaches. So with that, I'll turn things over to James.
Hello, everybody. I'm going to talk about the different greenhouse gas solutions. I'm going to address it a little bit differently than George did, but they are in alignment with the the solver that he described earlier. So he's done mainly all of the data setup and the overall solution from the megawatts. So we're going to kind of move through this a little bit quicker than I anticipated. But I'm also going to address it from a zonal approach first. Because it actually provides an easier discussion on the greenhouse gas neutrality that we have to discuss. So the things we're going to discuss in the settlement overview is how the resources for a resource-specific approach, they're going to receive a day-ahead greenhouse gas obligation that will settle at the relevant marginal greenhouse gas price. There is a need now to have an EAM marginal greenhouse gas neutrality and neutrality allocation. We either are going to allocate this to EDAM entity or to measure demand. And then we will carry this forward into real time. I don't do slides based on real time. We're only going to focus on a day ahead solution. For the zonal approach, we're also going to have a greenhouse gas settlement and a need for neutrality. But what is going to have neutrality is we're going to have a transfer obligation. That transfer obligation is we're going to calculate the transfer megawatts at the hurdle rate. And then the hurdle rate will either be distributed to the state regulator or to measure demand. Under that, both those consideration, we have to have neutrality to ensure that the greenhouse gas costs within the BAAs are accounted for correctly. So this is my slide of what George was doing. So here basically it's three BAAs. BAAs on the far left, lower left, BABs at the top, BACs on the far right. Now, when it comes into bidding, George addressed all this, but what I tried to do is do it more of a spreadsheet type of solution so you can see what the dollars would look like when we get in a couple more slides. The generator one in BAA is got a bidding in 300 megawatts at $90. And George, so as you can see, I'm trying to align this with the solution that we had that George discussed. Greenhouse gas or generator 3 is bidding in $300 at $70. Load is bidding in 110 as a price taker. Load 1, load 3, load 1 is in the greenhouse gas zone 1. Load 3 is in the BAA, but not in the greenhouse gas zone 1. It's a price taker at 290 megawatts of price taking. And then for BAB, we have generator 2, which is bidding in 300 megawatts at $80, and in zone 2 is bidding in for $4. Generator 4 is bidding 300 megawatts at $60. It is not bidding into either of the zone. It is not located in the zone. Load 2 is bidding in 300 megawatts as a price taker. Load 4 is 70 megawatts as a price taker. And then for BAAC, I have generator 5 bidding in 200 megawatts at $20. The generator 6 is bidding 200 megawatts at $30. Generator 7 is bidding 200 at $40, and generator 8 is bidding in at $50. Load 5 within the BAC is price taking for 400 megawatts. Now, I've also defined and aligned the ETSR pairs that we will have in settlements, because when settlements does its settling of the solution, we'll have ETSR pairs. And they're aligned with the the solvers T, transfer AB, transfer BA, transfer AC, transfer CA, transfer BC, and transfer CB. And you can see the P max, in this case would be a limit, is set at 999. So when the solver solved, there wasn't going to be any binding intertie, or the ETSR was not going to bind. So based upon the hurdle rate, and this, as I said, we're doing the zonal approach first, is that the solution is going to have generator 3 being awarded 100 megawatts, and it is setting the energy price at $70. The load in BAA, which is in the greenhouse gas region, is going to be awarded 110 megawatts as a price taker, but its price is going to be the energy price of $70 plus the greenhouse gas price, or the hurdle rate of $1. So it's going to be charged at $71. Load 3, which is not in the greenhouse gas region, is awarded 290 megawatts at $70 and will be charged at to $70. In BAB, the generator 2 was not awarded because, again, it was one of the very high price bidders, but generator 4 was being awarded 300 megawatts at $70. And load 2, which is in the greenhouse gas zone 2, is being awarded $330 or 330 megawatts at $74. This is 70 for energy, $4 for greenhouse gas. Making this distinction because of the discussion we're going to have on greenhouse gas neutrality. Load 4 has been awarded 70 megawatts at $70 for BAAC. Generator 5 was awarded 200 megawatts at $70. Actually, each of the resources generators within BAC was awarded 200 megawatts at $70. because we are transferring some energy between BAC to BAA and BAB. Load 5 is been awarded its load as a price taker at $70, so it's going to be charged for $70 the marginal cost. Now, as you can see a little farther down, is based on the transfers, I have 300 megawatts that is transferring from BAAC to BAA. This is the energy transfer, and this 300 megawatts is going to be priced at $70 because it's the marginal energy cost. The transfer between BAC to BAB is going to be 100 megawatts because it's sending energy from BAC. I think it's generator, I think it was 8 was going to BAB. Now, when we look at the solution, as you can see, is the transfers. I also want to identify the transfers. So in zone 1, we account for 110 megawatts of transfer from the non-greenhouse gas region to the greenhouse gas region in BAA. So this is going to incorporate all of the non-greenhouse gas regions. So as George described it, he had the big box that goes around BAA portion, a BAB portion, and all of BAC. So there's going to be 110 megawatts is transferring into the greenhouse gas region 1, and George referred to it as T1. It has a marginal hurdle rate of, it has a hurdle rate of $1. And then for greenhouse gas region 2, we have 330 megawatts that's going to serve the load in BAB of load 2, and that has a greenhouse gas a hurdle rate of $4. Now, when it comes to settling now, my generators are going to be paid at the marginal energy prices plus any applicable, just the marginal energy price for the load, depending upon where it's located, will be charged at the energy price plus the hurdle rate if it is having energy from a non-greenhouse gas region serving into the greenhouse gas region. So in this case, generator 3 is in BAA is going to be paid $7,000. The load in BAA is being charged $7,810. Load 3 that is not in the greenhouse gas region is going to be charged $20,300. Now I'm going to account for the greenhouse gas a little bit here because as you can see in BAA, if I add up all my charges and my payments, we're not neutral. Well, the first thing we need to account for is the fact that I had a transfer. And I had a transfer going from BAC to BAA. That was 300 megawatts. So from the settlement perspective, that'll look like a charge to BAC, like an exporting resource. It'll look like an export transfer. But in BAA, it'll look like an import transfer. So I'll see a payment of $21,000. Because we don't have any price separation, there is no need to account for transfer revenue, but it does bring the BAA more in alignment to being neutral. But we are still short. We're still short $110. So when we do the settlement for the zonal approach, what we'll do is we'll calculate what the cost for the transfer of the energy into the greenhouse gas region for BAA. That is going to be 110 megawatts at $1. So when I do my neutrality, I will do a greenhouse gas neutrality between the non-greenhouse gas region, and then BAA's greenhouse gas region. I'm going to account for this $110. I'm going to take that $110 and either pay it to load, which would bring us back in neutrality, or we will account for it if we are going to give it to the regulator and ensure that it's defined within BAA. So now we are neutral from BAA perspective. Similarly, for BAB, generator 4 is being paid $21,000, but load 2, which is receiving energy from BAC and has a hurdle rate of $4, it's being charged at $74. 70 for energy, $4 for greenhouse gas is being charged for $24,420. Load 4, which is not in the greenhouse gas defined area, is being charged $4,900. So again, we have the same neutrality issue that we have to account for. First, we have to account for the fact that I have transfers going from BAC to BAB. $7,000 is going to be the additional payment as a transfer import. But I'm also going to have to account for the transfer revenue or transfer greenhouse gas megawatts that are associated going from a non-greenhouse gas region to a greenhouse gas region. That's the 330 megawatts at $4. So that is $1,320. Now we are going to allocate that either to the load within BAB or to the regulator, but that'll look like a payment. So when it comes to the BAA neutrality, I'm going to see that BAB is now neutral because I've accounted for the greenhouse gas transfers between the non-greenhouse gas region and the greenhouse gas region. Now for BAC, this is pretty straightforward. I have each of the generator is outputting 200 megawatts at $70. So each of the generators are being paid $14,000. Some of that energy is used to serve BAA, some of it is used to serve BAB, and other is internal. So the load that's internal to BAC is being charged $28,000. But now as we go back to the transfer, I see that BAC, I have an export transfer both from BAC to BAA and BAC to BAB of $28,000 total. So now that brings BAC into a neutral settlement. So what the introduction of the greenhouse gas where you have to split a BAAs between greenhouse gas region and a non-greenhouse gas region, we are going to be introducing this greenhouse gas neutrality settlement. For the zonal approach, it's because we're not accounting for resources, it's going to be a more direct allocation to either load or to the regulator, but we'll be able to account for that energy that's going from a non-greenhouse gas region to a greenhouse gas region.
All right, let's pause here, check for understanding. Are there any clarification questions in the room? I do see a question from Mark Coleman. Mark, go ahead.
Hi, good morning. Sorry I missed the last hour or so, but I did hear a lot of the discussion. I appreciate the detail here. I'm wondering if we could just back the settlement up for discussion purposes, if I could just take it to a higher level. And I think we've struggled a little bit this morning with the characterization of the zonal approach. There was a statement that the zonal approach doesn't have attribution. It does have attribution. It just has more accurate attribution that is done outside the optimization. I think what you're showing here for zonal GHG settlement is one approach to the unspecified portion of imports. But the zonal approach proposed has two buckets of imports, unspecified and specified source. Only the specified source, the criteria are largely mirror what has already been established by CARB and is done outside the optimization, because the optimization, unfortunately, is getting it very, very wrong today, and we believe will continue to do so under the deeming approach. So as we talk about the zonal settlement, I think it's important to recognize that at a high level, for the unspecified bucket, the optimization will collect the money at the unspecified rate. The question is whether it's then the market operator, as Mary described yesterday, that purchases the allowances and retires them with that money, or whether you hand it to someone else to purchase the allowances and retire it. And I think, James, you're suggesting here measured demand. There is the ability to get more granular than that. As an example, you could allocate those dollars and the reporting obligation to the entities that are actually purchasing from the market. So if you had a scheduling coordinator that was balanced, maybe they don't get allocated. Whereas if you have entities that are using the market to fill their load need, they would get allocated. So we could more precisely allocate it. I think the part that's missing from this this morning, though, and Claire was starting to really get to it, is the zonal approach creates an opportunity for resource specific. And it's just that the criteria are met not through an optimization that miss attributes, but actually through clear criteria, and that settlement is not presented here. It's not in George's model, and it is relatively straightforward, and it doesn't need to be pseudo-tied. And so I think there just needs to be better dialogue around the zonal approach in terms of how it's being presented, including on the settlement. But I do appreciate the detailed numeric examples. I think you're right that we have this bucket of money that we have to decide, is it the CAISO that buys the allowances and retires them and reports, or is it given to someone else who is importing it? And that may be load or load and generation that has, loosely speaking, imbalances or is purchasing from the market.
Well, thank you, Mark. And you are correct, at least in that last part, is we have to come to more discussion as to how the greenhouse gas money that I've collected here is going to be distributed, whether or not it's to meter load, measure demand, or as you have indicated, it could be straight to the people who have to retire the credits, and whether it be the ISO or load or generation. That is an open discussion, but from a settlements perspective, using our previous principles, we typically will have a neutrality settlement that is allocated to either metered load, measured demand, or to the entity itself, and let the entity do it. So, but I am open for continued discussion in the allocation.
And I appreciate that. And I think that the key issue is we want to allocate the costs in the money and the reporting obligation accurately. I think that is really, really important, that we're not allowing external resources that are emitting not to bear any costs through the settlement outcome as we're seeing today, and we're not handing money to entities that aren't increasing their production and may not even be exporting. So I think one of the principles here has to be accurate allocation of costs and revenues consistent with the imports, because that's what we're trying to tackle here. And so I think what I would describe this as is one approach you're describing for the unspecified portion of the zonal GHG settlement, and that there are a few different options for that.
Well, thank you, Mark. I appreciate that.
All right, I see George has his hand up. Go ahead, George.
Thank you. Can you hear me? This is George Angelidis.
Yes.
James, I have two questions. I understand that the introduction of the greenhouse gas cost and the revenue that we collect from the greenhouse gas transfers generates the need to have a new neutrality, as you mentioned, for greenhouse gas cost at the BA level, and I understand why it goes at the BA level, since all neutrality is at the BA level. I wanted to ask two questions. That you mentioned that one way to achieve neutrality is by distributing the revenue to load, to meet, I think you said meter demand. I'm assuming that this will be not just the demand in the BAA per se, but the portion of the demand, the BA, that is part of the greenhouse gas regulation area, and I wanted to confirm if that was your understanding as well. And
so
then I have another related question.
Yeah, you are correct, George. So for the greenhouse gas transfer 1, where we have $110, that allocation would be to load 1 within BAA, because you have to offset the greenhouse gas collection from load 1 in BAA. Similarly, in BAB, it's going to have to be from load 2 because load 2 settled at the marginal energy price of $70, and also we collected their entire 330 megawatts with a $4 greenhouse gas hurdle rate. And so we have to offset it against the greenhouse gas transfer 2, which we've collected or paid out, in essence, $1,320. That's how we're going to maintain a neutrality across the greenhouse gas regions as well as the BAA.
Okay, that's fair enough. If if the meter is matching the schedule, then essentially the net settlement for the load in the greenhouse gas area is going to be at the LMP that is outside, the $70, since it's paying. Oh, actually not. I'm sorry. It's an uplift, but it may look like it's the same, but in the general case, it may not be, right?
Mm-hmm.
Okay. What happens if in this example, the greenhouse gas regulation area is overlapping with one BAA, so everything works the way we're discussing here. In the general case, you may have a greenhouse gas regulation area overlapping with multiple BAAs. Would you split the greenhouse gas transfer revenue by load ratio to the various BAAs that this greenhouse gas regulation area could be overlapping? Is that also a step there in this process?
Yeah, so if the greenhouse gas region is, let's say it's a single region, I don't have a greenhouse region 1 and 2 that they're overlapping, then what would end up happening is I would take the $1,430 and I would distribute it, or we potentially would distribute it to meter load across the loads within that greenhouse gas region. In this case, it'd be load 1 and load 2. Because those are the loads that we are collecting it from. I've got to align that greenhouse gas collection with the greenhouse gas payment.
Okay, thank you.
Now, I also want to identify something that if the load within, let's say, BAB load 2 actually was 335 megawatts, and I have only 330 megawatts attributed to being served that area from internal, I would expect that either it's coming from another internal generator, but if I don't have a perfect alignment, let's say the meter value is different, and I'm kind of addressing this to all the way to meter, I've created a 5 megawatt neutrality from greenhouse gas, because I will have charged that load at $74 at 335 megawatts, but I've only collected 330 megawatts of greenhouse gas transfers. So that 5 megawatts, the reason why we're contemplating allocating it back to meter load is because I want to bring that load back into neutrality.
Okay, so there is a level of complexity here with these load ratio allocations, this difference between meter and schedule, and all of that is taken care of, but there is certainly a level of complexity. So I'm just going to point out, if you follow the alternative of just simply surrendering the greenhouse gas transfer revenue to the regulator for the greenhouse gas area, then you don't have to do any of that, and it's just a very simple case for the market operator to stay neutral, and this gives the ability to the regulator to apply whatever regulation they want for this revenue. Am I right?
Yes.
Thank you. Let's go to Lindsay with the Energy Authority. Sorry, Lindsay, you can go ahead and unmute your line. Lindsay.
Hi, it's Lindsay.
Hi.
Go ahead. Sorry, it took a while for the unmute to pop up. It's Lindsay Schluckway with NV Energy. Hi, James. I had a question here because I'm keep going back between yours and George's slides with this example to try to visualize it a little bit better. But it looks like, so are you just assuming that generator 3 and generator 4 are supplying the GHG? Is that really just an assumption since you don't know with the zonal approach which generator is supplying it? I was kind of surprised that there wasn't the generator in BAC that had a GHG price.
So I'm not making the assumption that the energy is coming from any particular generator, but what I am accounting for is the fact that there was transfer from a non-greenhouse gas region into a greenhouse gas region. So if we see within, let's say, BAA, I have to account for 400 megawatts. Obviously, all of that can't come from generator 3 under this solution. We only awarded 100. So I'm going to get it through an energy transfer from BAAC, but it also is going to overlap with the fact that there was a greenhouse gas transfer that is being accounted for to serve that load as well.
Okay. I will continue to, I guess, look at this. Thank you.
All right, let's move next to Ken. Ken, you can go ahead and unmute yourself.
Hi. Yeah, I was just raising my hand to endorse George's comment that the beauty of the ISO managing retirement allowances is that it avoids where there may have appeared to have been revenue neutrality that had to be handled through another charge code of some kind. It diminishes that. It just removes that possibility altogether. And because of the marginal pricing, there's likely to be more of an excess over time.
Ken, thank you for your comment.
All right, back to you, James.
Okay. Without any more questions, what I'm going to do is move on to resource specific. I'm doing the resource specific second because it's a little bit more complicated when it comes to greenhouse gas neutrality. Again, the solution, George did a great job of outlining the solution, so I'm not going to go back through all of the bidding and what the overall awards were, with the exception that from the resource-specific approach, generator 6 was being awarded 110 megawatts of greenhouse gas obligations to serve load within the greenhouse gas region zone 1, whereas generator 8 and generator 4 were being awarded to serve greenhouse gas region 2. Now, generator 4 was 130 megawatts. Generator 8 was 200 megawatts. The marginal price for serving load in BAB was $4. For BAA is $1. So when it comes to a settlement, where this is going to have a little bit of a difference is now when I actually have payments. So I'm going to actually pay generator 4 based upon the obligation. I'm going to give it an additional payment of $520. Generator 6 is going to get an additional payment of $110, and generator 8 is going to get an additional payment of $800. Everything else that was, from a settlement perspective, was the same, but we also have to maintain that neutrality, and that's where I have to be able to account for the non-greenhouse gas region sending energy into the greenhouse gas region. So we were going to calculate what the financial transfer is between the two regions. And that financial transfer will then give us the accounting to bring the BAs back into neutrality. So I will calculate that I have energy going from generator 8 into the greenhouse gas region for BAB or zone 2, Same with generator 4. And now when I go and compare it to what was collected on load 2, it's going to bring us back into neutrality because I applied the 330 megawatts of load, got charged at $4 of greenhouse gas, and that will offset the $1,320 payment that was made to the generators in the non-greenhouse gas region. It just so happens that one of the generators in the non-greenhouse gas region is also in BAB. So we're going to have to make sure when I do neutrality, I'm going to have an explicit charge code that assures that the BAA's greenhouse gas collection and payments are neutral, and that's why we're going to have a specific charge for greenhouse gas neutrality. Same thing is going to happen for zone 1, which is between BAA and BAC, because I have 110 megawatts awarded or obligation from generator 6 to serve load in BAA. So I have to bring that back in neutrality. So we'll calculate a financial transfer amount that shows that I had greenhouse gas energy going from the non-greenhouse gas region into the greenhouse gas region. So you'll see a payment to the generator in the non-greenhouse gas region. You'll see a financial export for the transfer, and then you'll see a financial import into the greenhouse gas region of $110, which will offset the $110 that was collected from load 1. So now we're going to introduce, again, we have to introduce a greenhouse gas neutrality settlement to ensure that the BAAs are neutral and that the EIM area is also neutral. And I went through this pretty quickly as well, so I'm going to open up back for questions.
We don't have any online. I'm not seeing any in the room.
Okay. Because the hybrid approach was still under discussions, I did not create a settlement example for the hybrid, but it would look very similar. I believe it'll look very similar to the zonal approach. I'm going to take the comments that were addressed this week, and I will eventually create a hybrid greenhouse gas example as well. But in an overview, as I said before, the resources specific approach, we will give a greenhouse gas obligation specifically with the greenhouse gas resource, or a resource that has obligation to serve that greenhouse gas region. It's going to settle at the marginal cost of the greenhouse gas price. It does require the need to create a neutrality charge code for greenhouse gas between the non-greenhouse gas region and the greenhouse gas region, so it's being across the entire EDAM and WEIM footprint. And then we're going to have to make sure any of that neutrality is allocated out appropriately, whether it's to the entity, to measure demand. But we have to make sure that the BAA as well as the EIM area is neutral. For the zonal approach, we'll also have a greenhouse gas transfer obligation. We will calculate or settle that at relevant greenhouse gas hurdle price. And then, as I had indicated here, and I think Mark indicated another option, but we could either pay out to the state regulator correctly, and in the essence, the ISO retiring the credits, or I would allocate it to the greenhouse gas zonal meter demand, depending upon whether they're two regions or they are overlapping regions, would determine who would get the allocation. And that's pretty much the overview of settlements. I'm going to open up for any additional questions. Oops.
Not seeing any on the line. Are there any in the room? All right, I see Vijay in the back.
Thank you. A lot of this material I'm definitely going to have to go and digest again and listen to the videos. but I do have a comment to make, and I just shared the same with Anurag. So when I heard Claire's questions about clarifying zonal approach, and when I hear George's comments, and then the way I think you presented your assessment of how the settlement will work based on your understanding of the different approaches, I wonder if we could do a request to all three proponents of the different methods to do a complete breakdown comparison. And if we were to open up LWP's slide, they had this very good one slide that breaks down the approach based on the bidding, the optimization, settlement. So I think if all that is clearly explained once and compared all three methods, I think it'll help some of this work as well to clarify, because I'm hearing marginal price being used in the resource-specific approach. I'm hearing a different price approach in zonal. I'm hearing a transmission with may not impact how zonal is effectively used. And I'm hearing the hybrid is specified, focus more with unspecified imports. So I just want to request a big picture comment to, can we get a one consistent framework of comparison so we use the same language, same English words, and that'll help maybe with some of the
Sure.
Just a comment. Thank you.
Yeah, so based upon the discussions over the last 2 days, I've taken a lot of notes as to particularly the hybrid and then the proposed potential marginal or resource specific / zonal approach that was Mark referenced. And I will try to put together some type of comparison in the manner that you have expressed. Yeah, we needed to flush out some of the discussions over the last 2 days before I can actually do that comparison.
All right. Any other comments or questions? All right, I'll turn things over to you, Joanne.
Great. Thanks very much, James, and for all the ISO presenters and George. So round of applause for James. Thank you, James. Appreciate it. All right, a couple of items in closing. So in terms of the presentations that we presented yesterday and today, those are all updated and on the EDAM initiative webpage. We've also included the presentations from LADWP and from Mary Winkie, so those are available to you. I just want to mention that yesterday we talked about the next in-person meeting for the revised draw proposal. So we are going to likely be announcing next week, the August 29th and 30th, the dates. I want to appreciate our thank you to the GRC and to the RIF as we kind of modify and move things around to accommodate all of the many meetings I know all of you are participating in. But it looks like the 29th and 30th are pretty firm, and that will be in person, likely to be Sacramento, but the actual location is TBD. So please look for those announcements. Milos, did you want to go over some of the other milestones real quick?
Sure. Yeah. And again, just to extend our deep appreciation for everybody that traveled and everybody that took time out of their day to listen over the last couple of days into the workshop discussions. I think it's been a good discussion, and I think this is our last workshop from the series of workshops that we started on July 11th. And together with the stakeholder comments, as well as what we heard in these workshops and the feedback that we received, that's going to help shape our next iteration of the revised draw proposal, which is targeted for August 11th. And that's next really for the team up here and others that are back in Sacramento, is to roll up our sleeves and take that feedback now and write that next iteration of the straw proposal for your review. And as Joanne said, then we're targeting the stakeholder meeting on 29th and 30th to give you some additional time, a couple of weeks after publication of that revised straw proposal to digest it. And it gives us a bit of time to prepare materials as well for the stakeholder in-person discussion. So again, really appreciate all the engagement, all of the attention and the effort that you've taken here for the last 2 weeks of workshops that you spent with us. I know it's been a fairly robust 2 weeks on a variety of different topics, but I want to assure you that we've received a lot of good feedback and a lot of good ideas that will find their way into the straw proposal. So really appreciate it. And again, thank you everybody for taking the time.
Thanks, Milosh. So a couple other things as well. I just wanted to put a plug in for the ISO Stakeholder Symposium. We are going to be holding that in Sacramento at the Safe Credit Union Convention Center, November 9th and 10th. For those of you who are participating, and we hope we see all of you there, registration is open. And if you want to take advantage of the early bird rate through the end of July, that's available to you. So as Milosh mentioned, thank you to all our presenters. I do want to thank the LADWP team and for Mary Winkie for your presentations. And also a special thank you to Pacific Core for co-hosting today's meeting and making that possible. And again, thank you to all stakeholders who attended virtually. I know today we had over 150 participants, so thank you for joining us virtually and participating in the conversation. And for all of you who traveled here to Salt Lake City, thanks for being with us. We do have lunch next door. For those of you traveling, it is boxed lunch, so you can certainly pick up your lunch and go. You're also welcome to stick around and eat lunch here on site. So thanks again, everybody, and safe travels. Thanks to the ISO team. Thank you.